Okay, and I think I am live now, so great. Okay, yeah, let's get started. Today we're gonna start chapter 8, like I said, or sorry, chapter 7. Chapter 7. I kind of want to I'd like to go through it rather quickly. Like I said, I don't think that we can finish it by the end of the week, but we can certainly try. So yeah, I think what our goal is today, I'd like to do the first 2 sections today. Often I'll spend like a couple of days on one section, like if it's a big section. This is I don't want to say that this chapter isn't important. It is important, but I don't think it requires the same level of care and detail that we spent with like the last section, like rational equations. Rational equations, like that's a massive exercise in algebra. So if you felt confident in rational like solving rational equations and simplifying rational expressions, then that's like really good. Because I mean one of the biggest issues that students have in university with math is with algebra. And what we just did, we did a huge, like a major topic in algebra. So if you feel comfortable with this stuff that we just did for the past couple of weeks, then that's fantastic and you're in good shape. That's one of the most important topics of the year, in my opinion, is just having some nice fluency with algebra, being able to cancel things, being aware of non-permissible values, factoring things, finding GCFs of rational expressions, least common multiples of a rational expression. I think that those are some really important topics. So that said, chapter 7 is important, but it's more like the end of chapter 7 that things get really important. In particular, when we start looking at reciprocal functions. In any case, let's talk a little bit about absolute values, and then we'll take it from there. So absolute values. Okay, so this is chapter 7. Okay, so we're gonna be following chapter 7 fairly closely, but not as closely as the other chapters. So I'm gonna try to sort of get the move on here. So I'm just going to quickly define what an absolute value is. You have probably heard of absolute values. If you haven't, that's okay, but you may already be aware of what an absolute value is. And then we're going to basically leave it at that, and then we're going to start graphing absolute value functions. Okay, so that's our goal for today. So our goal, and sometimes goals aren't met, which is okay, but our goals for today is to do 7.1 and 7.2. And if I assign any homework, it'll be from 7.2. So it's not that we're skipping 7.1, but we're just trying to go through it rather quickly. So what is an absolute value? That's the first thing that you might be asking yourself. So what is it? What is this thing that we call an absolute value? Well, the way I think about it is it's how. So here's our question. Our question would be, what is it? Our answer could be, so how big is our number? Okay, that's really all it is. It's so, you might be asking, what do you mean by big? Like, what does that actually mean? Well, like what I would think of as big is, or in other words, how far away from 0 is our number. And that's really it sounds like a sort of a wishy-washy kind of hand-wavy way of describing it, like how far away from 0 is our number, but that's actually one of the most accurate ways of thinking about it, because when you start learning about things called complex numbers, you can take the absolute value of a complex number, but it's the best way to describe that is actually the distance between the number and 0. So this is actually a very accurate way of describing it, is how far away from 0 is our number. So it sounds like that's kind of like not the best description that there is, but I just want to say it actually is probably the best description of absolute values, at least that I know of. There's a few other sort of answers. So another answer that you could have is the positive version of a number. Okay, so like if your number already is positive, then the absolute value of that number is just the number itself. If you have a negative number, then the absolute value of your number is now the positive version of that number. So let's start actually talking about what it is, like in a more concrete way. So the actual definition, so the real definition of the absolute value is okay, and I'm gonna just write it. Let me give myself just a little more room here. I'm gonna write it down here. So the real definition of the absolute value is the following. The way we write it is we have two vertical bars like this, and it's important to make those like really tall bars. If you make them kind of short like this, it looks like the number 1. And we're not talking about the number 1. We're talking about absolute values. So make sure that when you draw your absolute value bars, make them nice and tall. Otherwise, I will think that you're talking about the number 1 when clearly you're not. So the absolute value of x is equal to two possible things. There's two possible values for the absolute value of x, and it depends on the value of x. So the absolute value of x is just going to be x if x is greater than or equal to 0, and it's equal to negative x if x is less than 0. And that's the formal definition. That's the very precise definition. It doesn't really, it might not help you understand what it is right off the hop. You might see this and say, I have no idea what that means. What does this little bar mean? But really, all this is saying is it's kind of like a decision tree. So, like, let's try to figure out what the absolute value of 19 is. So there's my absolute value of 19, and you can see the way I drew it, the 1 here is much smaller than the absolute value bar. So it's very clear to see that this is not the number 1191, right? You could imagine someone writing the absolute value of 19 and someone else mistaking it for 1191, right? So these bars are nice and tall. I've got nice tall bars. Well, let's follow our decision tree. Okay, well, what is it? Is our number greater than or equal to 0, or is it less than 0? So just to be clear, this means positive. This means negative. Okay, well, in this case, our number is positive, so the absolute value of 19 is just 19 itself. Let's try another one. Let's do the absolute value of negative 7. Okay, so the absolute value of negative 7 is, well, let's have a look. Is it positive or negative? Well, in this case, it's negative, right? Our negative 7 is less than 0, which means that the absolute value of negative 7 is the negative version of it, or in other words, positive 7. So this would be negative 7, which is positive 7. So that's pretty much it. So the absolute value of a number is just the positive version of that number. Now, what was I talking about? Let me just rewind for 2 seconds. What was I talking about over here? Like how far away from 0 is our number? Well, let me just quickly describe what I mean by that. So here's my number line right over here. I'll make a better one. Here we go. Doesn't look much better until boom, got the snap function on, the geometry function. Okay, so here's my number line, and here's 0. Now 0 is arguably the most important number on the number line, because this number is not positive and it's not negative. It's kind of in its own realm. Some people call it neutral. Now you could take a look at this and kind of add some little tick marks on here, and these tick marks represent the integers, right? I'm not doing a very good job of lining them up evenly, but that's fine. So let's say we have this number, what is this, 1, 2, 3, 4, 5, 6, 7, 8. Let's say that 8 is over here, and let's say that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say that negative 9 is over here. So if we wanted to find the absolute value of 8, what we would do is we would look at the distance from here to here. What is that distance? So the distance is 8. Right? And distance is always positive. You never have a negative distance. So the absolute value of 8 is equal to 8. The absolute value of 9, or negative 9, the absolute value of negative 9 is, well, let's take a look at this distance. So the distance between negative 9 and 0 is 9, right? And that, I think that's probably the best way of describing it, is just how far away from that, how far away from 0 is our number. And that's really all section 7.1 is about. I mean, they get into things that are slightly more complicated, and I think it would help if we did a couple examples, but that's really the gist of it. Just a quick introduction to absolute values. So let's do a quick example. I'm going to do, let's see here. I'd like to find a good example. Yeah, let's do this example here. I'm going to take a photograph of it to save myself the trouble of writing it. 1 second here. Okay, this question right here. And people say that you never use the camera on an iPad. I know. Although I don't think I've ever used it for anything other than our live streams. And now I can't. Okay. Can I copy it now? Edit, copy. Shoot, how do I copy it? Because I want to move it to the other page, but I don't think I can. Shoot. Come on. Okay, I'm gonna just put it here, and then we'll just have to read it over here. Okay, that's just gonna have to do. Okay, example 4. By the way, this is on page 362. Oops, page, and you can't read that. How about this? Page 362. Okay, go back to here. Okay, so yeah, example 4. Change in stock value. Isn't that cool about math? Like, math, you can, like, if you have a really good understanding of math, you can make a lot of money. One of my friends, who we would have met him actually, if we had that. Remember, we had the field trip scheduled. Yeah, we had that field trip scheduled. And as I'm pretty sure that I still haven't actually asked him if it was him who was going to do that, but I'm quite sure that it would have been him who would talk about actuary science. And that is a very lucrative career. He makes a lot more money than I do. If you're really good at math and you enjoy math, and you also want lots of money when you grow up, then you should consider actuary science. Although, not that this question has anything to do with actuary science, but I'll quickly write that down in case any of you are kind of thinking about careers. But actuary science. Get a good degree in actuary science, and you will have lots of money. So if you didn't know what actuary science is the mathematics behind insurance policies. So an insurance company like Great West Life or Manulife or Blue Cross, any of these insurance companies, what they do is they look at like what is the amount of money that we can charge and give people insurance. So basically looking at the life expectancy of certain people based on any kind of disease that they might have, how reckless their lifestyle is, if they have substance abuse issues, that kind of thing. So look, it's kind of a weird area of science, but you make lots of money from it. So if you want a life with lots of money, and it's not exactly like, I wouldn't say that actuary science is evil. Like, I don't think you're taking advantage of anybody. But what you are doing is you're saying, okay, as an insurance policy, how can we continue to make money while still providing the benefit of giving people like life insurance? Like, so if they're to die, then giving their family $1 million. How can you still make money and have that sort of situation? So really, really good way of making money, and it's honest money, and it's a very like cushy job. Like you don't have to, like, it's not very stressful. I think that there's a lot of career satisfaction. But yeah, you make quite a lot of coin. Anyway, this question is not about actuary science. I don't even remember why I started talking about actuary science. This question is about the stock market. Probably because of money. Yeah, probably because of money. Okay, so on stock markets, individual stock and bond values fluctuate a great deal. Yeah, absolutely, especially when the markets are volatile, like they are right now. Now is a good time to buy stocks, I guess. Maybe not. Maybe it's the worst time to buy stocks. I have no idea. Yeah, I will certainly not provide any kind of advice with regard to the stock market because I wouldn't want to be held liable. Okay, so anyways, a particular stock in the Toronto Stock Exchange, the TSX, opened the month at $13.55 per share, dropped to $12.70, increased to $14.05, and closed the month at $13.85. Okay, so let me just quickly write those numbers. So it's opened the month at $13.55. Okay, then it dropped down to $12.70, and then increased to $14.05. So we were at $14.05, and then it ended the month at $13.85. $13.85. I think my head is probably covering that. Yeah. Oh no. Okay. Where are we? Okay, determine the total change of the value of this stock for the month. Okay, this total shows how active the stock was that month. So what they're saying is, like, between here and here, there is a change, right? The stock market changed, and the value of this stock was changed. So what was that change? And they're saying, what was this change, and what was this change? All of these different changes contribute to how volatile that stock is. If you don't know what volatile means, volatile just means volatile. It means like unpredictable, and subject to change. So it changes a lot in a way that is unpredictable. Yeah, eat the rich. Yeah. So $13.55 to $12.70 to $14.05 to $13.85. So let's see how volatile this is. So you can imagine if it changes a lot, right? If there's like an increase and then a decrease and another increase and another decrease, then that means that is really volatile. So we should get a nice big number. So that's where the absolute values are going to come in. So the absolute value, what we're going to do is I'm going to take this one. I'm going to have the absolute value of $13.55 minus $12.70. The absolute value of these guys. And I'll make really tall absolute value bars so we know that these are absolute values and not ones. Okay, So that's the first change. And the reason I'm putting the absolute value sign on it is because I don't care if it's an increase or a decrease. So I don't want to have to worry about lining up my minus signs so that the bigger number comes first. I want to just, boom, be able to just write the first one minus the second one. Next up, I've got 1270 minus 1405. And then finally, I'm going to add, and I think my head is covering this, I'm going to add 1405 minus 1385. Give me 1 second and I'll bring this up. There you go. And that's the expression that we're going to be evaluating. So I'm going to use my calculator for this because I don't want to have to subtract decimals. But 1355 minus 1270. Pardon me? Yeah, 0.85. So this is 0.85 plus the absolute value of 1270 minus 1405. Yeah, 1.35 or negative 1.35. Okay, plus, and then 1405 minus 1385 is 20 cents. That's right, so 20 cents. Okay, so adding all of these up, well, let's just get rid of the absolute value signs first. So we will have 0.85 plus 1.35 plus 0.20. Let's quickly add those up. I've got 0.85 plus 1.35 plus 0.20, and this is equal to 2.4. Fantastic. So that's a typical absolute value question, is to be looking at just the positive version of something. So so just because, like, it's almost as if, like, so, like, let's say that this is your house, this is your home, and let's say you go for a walk, right? And you go for a walk in this direction, and then you walk back over here, right? Taking a look at the absolute values, you're looking at the distances. It's like, how far did you walk from here to here? Maybe you walked 10 meters. And then when you went back over here, you walked another 5 meters. Now there's two sort of interpretations of this. One interpretation is that I walked a total of 15 meters. Another interpretation is that I walked until I was 5 meters away from home. Right? Because the distance from here to here is still just 5 meters because I backtracked. Right? So if it was an absolute value question, then you would consider this, okay, and then you would consider this, and you would consider them both to be positive values, right? So this would be like the absolute value version. So that's kind of what's happening here, right? Is that we're not looking at just the difference between the first value of the stock and the last value of the stock. We're tracking all the change that happened between them. So that's kind of what's going on there. Okay, so that's 7.1. I'm not going to assign anything from 7.1. I want us just to jump right into 7.2. Okay. So 7.2 is absolute value functions. Okay, 7.2 is absolute value functions. Okay, so the idea of an absolute value function is to graph and see what absolute values look like on the Cartesian plane. Okay, and that's what we're going to do. So I'm going to start off with kind of a thought experiment, and this thought experiment is also in your textbook. I think it's on page 368, so I'll just write that down. If you want to follow along in your book, you can if you want, or you can just stick around in the video, whatever makes you learn the best. So the absolute value function can be described by, well, a number of things. So let's start off with a table of values. Okay, a table of values. Okay, now in this table of values, I am going to write x in one column, and I am going to write the absolute value of x in the other column. Okay, and I know that this isn't exactly the same way that your textbook does it, but it's very similar. But I kind of prefer doing it like this. So this is using a table of values is a great way to start graphing an equation, right? So if you have a table of values, okay, let me just do this and then this. What you're doing is you're basically just choosing different values of x, right? And then you're seeing, and that's what these are, the different values of x. And then once you figure out what the corresponding value is in relation to x, then you can say, okay, well, when x is -2, the absolute value of x is +2. So you'd have a point there. And then you connect all of those points, right? That's what we do when we make a table of values. And we've done this sort of thing before. In particular, I think we first started doing it with quadratic functions, like a long time ago, back when we were still in school. Okay, so let's throw in a few values. I really like to use negative values. That's where I like to start off. So let's try -3, -2, -1, 0, 1, 2, and 3. And we'll calculate the absolute value of each of these. Okay? So when x is -3, the absolute value of x is +3. When x is -2, the absolute value of x is +2. -1 goes to +1. 0 goes to 0. 1 just stays at 1. 2 stays at 2. And 3 stays at 3. And that's it. So taking a look at this, I'm going to start plotting some points on here. So the point -3, 3 is over here. The point -2, 2 is over here. Point -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. And you can kind of see what's going on here. The function starts off kind of looking as though it's going down. It almost looks like the function y equals -x, right? That's kind of, I'm going to put it in a bubble because that's kind of what the function is thinking, right? It's like, it sort of looks like it's y equals -x, but as you get to the other side, something happens. It's almost as if there's like a reflection, or like it bounces off of the x-axis, right? This is our x-axis here. This is our y-axis. So it's almost like it bounces off, right? Like it's like that. It's like it's like you're throwing a ball against the ground, and the ball is going boing, and then it just bounces back up. So that's what's happening here. And on this side of the graph, so I'll kind of make a little thought bubble. On this side of the graph, it kind of looks like y equals x. And isn't that funny? Because on this side, these are negative x's, and these are positive x's, right? On the left-hand side of the graph, you have negative x's. On the right-hand side of the graph, you have positive x's. And look at that. This is consistent with our original definition, right? When x is positive, we have just x. When x is negative, we have negative x, which is exactly what this is all about, right? It's completely consistent with our original definition, so it actually does work. Okay, so that's kind of what we're going to start off with. Is we're going to start with graphing. We're going to start off with graphing absolute value functions using a table of values. So that's kind of how we begin, is we start doing it with a table of values, and eventually what we'd like to do is we'd like to gain the ability to graph these absolute value functions without using a table of values. So let's try a couple more. Let's try this one here. Let's try to graph, e.g. let's graph this guy. And again, this is in your book. This is on page 370. Okay, let's graph, what is it? What are they doing? Y equals the absolute value of 2x minus 3. y equals the absolute value of 2x minus 3. Okay. Okay. So what I'm going to do, I'm going to do this in two ways. I'm going to start off by graphing it with a table of values. And then what we'll do is, yeah, it kind of looks like a parabola, but more like a V. Yeah, absolutely. So what we're going to do is we're going to start off by doing a table of values, graph the table of values, and then I want to show you a slightly more sophisticated and a slightly more, I guess, efficient way of graphing these things. Okay, so let's start off with the table of values. I'm going to write TOV for table of values. And the table of values is going to have, well, it's important to have some negative values in here and some positive values. So let's start off with, I don't know, how about negative, let's do -3, let's do -2. Let's just do the same ones that we did last time. Okay. Okay, and you know what? I think I should give you like I'm gonna give you a minute to try to solve some of these. Okay, so I'm just gonna punch this in here. I'm gonna give you 1 minute because I do want you to actually have a little bit of practice with this stuff. So here's 1 minute. Try to fill that in the best you can. Okay. Okay, so let's just jump right on into it. So this one here, I've got, well, it's going to be the absolute value of 2 times -3 minus 3, which is equal to, well, 2 times -3 is -6. -6 minus 3 is -9, so it's the absolute value of -9, which is +9. Okay, same thing over here. I've got the absolute value of 2 times -2 minus 3, and that is, well, 2 times -2 is -4, minus 3 is -7. So this is the absolute value of -7, which is +7. Keep going. 2 times -1 minus 3, that's -2 minus 3, which is -5. The absolute value of -5 is +5. Now I've got the absolute value of 2 times 0 minus 3, which is 0 minus 3, which is -3. Absolute value of -3 is +3. Keep going. I've got 2 times 1 minus 3 is, well, 2 times 1 is 2, minus 3 is -1, so I've got the absolute value of -1, which is +1. Keep going. 2 times 2 minus 3, 2 times 2 is 4, minus 3 is 1, so I've got +1. Absolute value of +1 is 1. And 2 times 3 minus 3, that's 6 minus 3, which is 3. Absolute value of 3 is just 3. So I've got 9, 7, 5, 3, 1, 1, 3. Great. Now let's graph this. Let me quickly make a little set of axes here. That looks good. That looks good as well. Okay. So I'm going to start off with the first point, -3, 9. I'm going to have to move this down a little bit. That's better. So I'm going to go with -3 and 9. So that would be this point here. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. That's my first point. My next point is -2, 7. So that goes down 2. Next point is 5, which is this one here. And then 0, I've got 0, 3. And then 1, 1. and then 2, 1, so I'm here again, and then 3, 3. So 3, 1, 2, 3. There we go. I'm going to make these a different color just so they stand out a little bit better. So I'll just go over on top of them. How about, there we go. Here's a dot, here's a dot, there's a dot, there's a dot, there's a dot, there's a dot, and there's a dot. Okay. So the absolute value, just as it is, let's take a look at what is in here. This is a linear function. Like if I asked you to graph y equals 2x minus 3, well, you'd say, okay, well, that's a linear function because this is a line, right? It's y equals mx plus b, right? This is a line. So that means that this is going to be our line here, except what's happening is that the line never becomes negative, right? It pops up over here and becomes positive again. So that's how we're going to connect our dots, is that we make one straight line, but that straight line is not allowed to pass through that x-axis and go into the negatives. So it kind of bounces up right there, right smack dab in the middle, and there we have it. So this is our graph here. So I kind of want to show you what's actually happening here. So we could spend every question just making a table of values and then taking it at that. But what I want us to do is I want us to look at like, what about y is equal to 2x minus 3? Okay, so let's head over to Desmos and compare this graph over here, the y equals 2x minus 3, and let's compare it to y equals the absolute value of 2x minus 3. Okay, so I'm going to head over to Desmos. There we go. Okay, and I'm going to steal my keyboard. Give me 1 second. Stealing it from myself. Okay, and I now can't see anything on YouTube or Discord, but I can hear you. So if you're yelling at me on YouTube, I'm sorry, I can't see it. Okay, so let's graph. I'm going to say that f of x is equal to, what was it, 2x minus 3. Okay, this is the function 2x minus 3, right? It's a linear function. Its slope is 2, right? There's its slope right there, and its y-intercept is -3, right? We've been graphing these things for years now. There's a few key values, right? It has a y-intercept of -3, like we just said, and it also has an x-intercept of 1.5. So this is our graph of y, or f of x equals 2x minus 3. Let's try the absolute value of f of x, like that, and look at what's happening here. So I'm gonna hide this one. Okay, so I can show and hide the original function, but when I hide it, you can see that it's pretty much just that function y equals 2x minus 3, except it's just reflected against the x-axis, right? Let's take a look at what happens with some other functions. So like this is y equals x, right? And then all of a sudden the green one is the absolute value of that function, right? So it's really just, you know, if I switch these, this is y equals x, right? But then the absolute value of it is saying, hey, we're not allowed to have, like, these are supposed to be positive. We're going to make these ones positive. So the further negative they are, when I take the absolute value of it, the further positive they are. So that's why we get this kind of thing. But here's what's going to sort of come up in the next couple of days, and hopefully we can kind of see this by the end of the week. What would happen if we had a function like y equals x squared? X squared. Oops. X squared. Oops. That's not what I meant to do. X squared. There we go. Okay. So here's our function y equals x squared. Let's get rid of this. The absolute value of this, I don't know. I don't think it's going to be any different, right? It's pretty much the same thing because all of these values are positive. And same with this. Like if I have x squared plus let's have this value of a is equal to 1. So now I can drag this quadratic up and down. So So this is my function f of x. And let's see what happens if I actually start to have some negative values in here. And this is where things get kind of cool. So this is my quadratic function, right? It's x squared plus a, and this slider here that I introduced changes the value of a as I drag it up and down. Okay. Let's see what happens when we take the absolute value of this function. So I'm going to show the absolute value function. I'm going to hide the original function, and let's see what happens. I think it'll be pretty cool. So this looks pretty normal, pretty normal, pretty normal. And then as soon as we go into the negatives, we get this sort of reflection going on. Okay? And this is where absolute value stuff gets more interesting, in my opinion, is when you get to actually graph these sort of like reflections and things like that. So this is I think that's a pretty interesting shape. It kind of looks like a W. So yeah, I think that's pretty neat. So that's where absolute values start to really shine. I think is where you get these interesting shapes that you know seem a little bit unintuitive, and they seem sort of like asymmetrical or something. But yeah, so our goal for the end of this chapter is to be able to graph this kind of thing. So if I were to give you like the absolute value of x squared minus 5, I'd hope that you'd be able to graph this by the end of this chapter. So that's kind of what we're headed towards. So I'm gonna go back here, put my keyboard back, and where are you guys? There you go. Is anyone yelling at me on YouTube? No? Okay, we're good. So we're going to leave it there. It's 3:15 now, or 3:14. So let's talk about our exit slip. By the way, yesterday I read a lot of, or actually I should say I read all your exit slips about the final exam. I really like what I heard. I'm gonna spend the weekend sort of thinking about the final exam, and I'll come to some kind of conclusion about what we're gonna do by the end of the weekend. So by Monday's class, I'll have a little announcement for you. I'm kind of leaning towards the idea of just having it be an option, but I'll let you know by Monday what the plan is for a final exam. So as for today, the exit slip is the following. Here's the exit slip. The exit slip is the following. Let's see here. Let's make something easy. What's the absolute value of 2 minus 3? Okay. Give me the absolute value of 2 minus 3. Something simple. Yeah, punch that in. Yeah, I hope you guys are doing well. I'm gonna sign out, and I guess I'll talk to you guys tomorrow. So have a good day. Bye, guys. Bye-bye, YouTube.